Thank you very much, Vice President Pence, for...
In December 2017, U.S. President Donald Trump made an official statement. The United States intends to send its astronauts to the moon again. A few years earlier, Barack Obama stopped any funding for the latest American lunar program, Constellation, which was launched by his predecessor, who declared that it was unwise to spend huge amounts of money on repeating the old Apollo program, which cost the United States almost $30 billion. The amount of money was huge, even for such a rich country.
And now the new leader has returned to the topic of space. He's managed to increase the budget of NASA substantially. But why is there such a sudden interest in the moon? It is known that Trump is a successful businessman, and he has an eye for profitable deals. So is this a commercial project of the White House? Or maybe just a pretentious boast by a U.S. president known for his colorful remarks? Or maybe they found something on the moon that has again ignited interest in it with a newfound query. Let's try to answer these and other questions and recall the history of lunar explorations along the way.
Other world powers weren't surprised by the plans of America to return to the moon. Moreover, in Russia, in Europe, and even in Asian countries, different countries are already working on their own lunar programs. For example, the Russian Space Agency has announced that in the next 20 to 30 years, Russian astronauts will land on the moon. And it's even planned to build a permanent base there. The European Space Agency is developing an ambitious program, Aurora, which also involves long-term human stays on the moon in the future. China has also announced its plans to explore the moon. What's more, they've already successfully landed an unmanned module on its surface.
The Chinese landed the spacecraft in the Mare Imbrium, or Sea of Showers, not far from a Russian moon rover, but it covered a distance of only 100 meters and then stopped. It is unclear why. Though the expedition had been planned to last longer, the station continued to transmit information about the surface and the temperature.
It turns out that not only 2 or even 3 states are heading for the moon in the 21st century. This new moon race is beginning with a much more crowded field than it was 60 years ago.
Nowadays, many countries want to take part in exploring the moon. Russia, the USA, Japan, India, China, and even the United Arab Emirates are all in the game. And the European Space Agency, of course.
The moon is a large astronomical body with a constant orbit that is closest to Earth. It affects many terrestrial processes, ranging from tides in the world's oceans to our biological rhythms. Based on its phases, many calendars have been compiled, and agricultural activities and religious ceremonies have been planned. At all times, the moon excited the minds and aroused the interest of mankind. But only in the 19th century did people begin to think seriously about flying to it. And by the middle of the 20th century, that dream became reality.
The era of space flights began in 1957, when, for the first time, an artificial Earth satellite was launched outside the atmosphere. It would be 4 years before Soviet cosmonaut Yuri Gagarin became the first man in space, but it was already clear that new spacecraft would explore the space. In early 1959, the first lunar research probe, Luna 1, was launched by the USSR. It passed by the moon, and for the first time in history, a man-made object entered orbit around the sun. It continued operating for a long time.
Luna 1 was the first spacecraft to take photos of the far side of the moon, and at first, many scientists refused to believe it.
And although the first automated probe did not land on the lunar surface, it was used to obtain very valuable information about the external background radiation of our planet, the solar wind, and the lack of a magnetic field on the moon. This was the first research data about space obtained from outside the Earth.
At that time, there was a rivalry between the two superpowers. In fact, the Cold War was well underway. The USA and the USSR, the two victors in World War II, began to compete in many spheres, including technology.
In the spring of 1959, the American space program Pioneer 4 set off for the moon. It also gathered important information. However, the first man-made object to reach the moon was a real breakthrough in the history of mankind, and the Soviet spacecraft Luna 2 accomplished that in the fall of the same year.
The first probe to touch down on the moon happened in 1959. Luna 2 landed here in the center. Actually, at that time, it was very difficult to get to the moon, and NASA managed to land its first probe only in 1965.
Another achievement was more photographs of the previously uncharted area of the far side of the moon, which were obtained thanks to the Soviet space probe Luna 3.
These are the pictures from Zond 3. They had a better resolution. There was not as much noise as in the earlier pictures. Thus, the first complete map of the moon was made. On the other side, it turned out that there are very few seas, less than 3% of the surface. The surface there is covered with craters.
The first data about the visible side of the moon was obtained long before the era of space exploration. In the 16th century, when Galileo observed the Earth satellite through his telescope, he was able to see craters, mountains, and even determine the approximate height of the peaks. It was Galileo who first called the dark spots on the moon seas. They can be seen even with the naked eye at night, with a clear sky. Scientists at various times gave them quite exotic names.
The Sea of Serenity, the Sea of Tranquility, the Sea of Nectar, and others. And when we look at the moon in its last quarter, we can see the ocean of storms, the Sea of Showers, the Sea of Moisture, the Sea of Clouds. Did you notice the difference in names? Well, at the time, the moon was believed to influence the weather on Earth. In its first quarter, the moon was thought to bring clear weather. In its last quarter, rain.
This is what the modern map of the moon looks like. There are many other geographical names on it: seas, craters, and valleys. Such a map was made possible thanks to the data revealed by those first spacecraft ever to achieve lunar orbit.
The mid-1960s was marked not only by the Cold War and the arms race between the two superpowers, but also by the space race, and in particular, the moon race. Despite all of the Soviet Union's successes at exploring space and the moon, the United States made an unambiguous pledge. We will be the first to land a man on the surface of the moon. And America kept that promise. In 1969, Neil Armstrong made his historic step, which truly marked a gigantic achievement for mankind.
Although Soviet and American planetary probes had successfully flown around the moon several times and landed on its surface, the presence of an actual human being there was indeed a great achievement for civilization. Since then, in addition to Neil Armstrong and his crewmate Edwin Aldrin, several more astronauts have been on the moon.
6 landings on the moon were carried out by American astronauts. That is, 12 people have been on the moon. These are very courageous people. They needed all their courage because every step was made for the first time.
In total, since 1959, about 30 landings of various spacecraft have been made on the moon. It is said that the USSR lost the moon race to America, but did it? After the success of the Americans, the Soviet Union abandoned the costly attempt to land its own cosmonauts on the moon. But the National Space Program continued.
There were several more Soviet probes, for example Luna 5, Luna 9, and Luna 10, which studied the moon's surface in detail, and we discovered that there were many things connecting the moon and the Earth, which is very important. It became clear that the moon is actually quite strongly influenced by the Earth. It has so-called mascons, or mass concentrations under the surface, which creates a difference in crust thickness between the Earth side and the far side.
In the 1970s, Soviet specialists preferred to send equipment rather than people to the moon. Soviet radio-controlled lunar rovers traveled dozens of kilometers across its surface. They collected a lot of data about its soil, made and transmitted a large number of photographs of the lunar landscape to Earth.
В 1970 году отправили
In 1970, the Soviets sent a huge spacecraft, Lunokhod 1, or Luna 17, and then, sometime after that, Lunokhod 2, which traveled 25 miles across its surface.
39 километров.
They were followed in 1970, 1972, and 1976 by Luna 16, Luna 20, Luna 24.
Это Луна 16, Луна 20, Луна 24.
Soviet probes delivered samples of lunar soil to Earth, which were immediately sent to specialists for detailed analysis. This is moon sand. It is still kept in the Museum of Extraterrestrial Matter at the Vernadsky Institute of Geochemistry and Analytical Chemistry in Moscow.
The moon and Earth are very close in their isotopic composition. This is very important. They have the same isotopic composition of oxygen, titanium, and tungsten. This is of great importance for understanding the common origin of the moon and Earth.
Some scientists believe that the moon is the younger sister of our planet, and it was formed several billion years ago when a gigantic cosmic body hit the Earth, which didn't have any life on it yet. However, in recent years, this hypothesis is being increasingly questioned. Many scientists now think that the moon and Earth were created at the same time.
Земля и Луна
Earth and the moon were formed from a large gas and dust cloud of enormous size.
огромных размеров. Это газопылевой
This gas and dust cloud had a certain torque, which is characteristic today for the Earth-Moon system.
системы Земли.
We know that for sure. But gradually, the gas was blown out of the cloud.
Оно так и существует. Но постепенно газ выдувается,
And when the gas was blown out, the cloud began to shrink,
начинает сжиматься,
and it started to collapse.
коллапсировать. Когда оно
When it imploded, it had the same torque. So there was a process of fragmentation, and it was divided into parts.
вот эти два фрагмента
These two parts were the germs of Earth and the moon.
зародыш Луны.
However, Russian scientists believe the moon, unlike Earth, was formed much faster.
Вот расчет
Calculations show that if one object was 4 times bigger than the other, it would have grown 25 times bigger, and the second one will have grown only 30%. Most of the matter would be attracted to the larger mass. It just took Earth more time to form. Earth needed 120 million years to become fully formed. While for the moon, scientists believe the period of formation was just 50 million years.
It became clear how the moon had evolved. On Earth, geographic processes actually hid all these signs of the early history of the planet's evolution. But the moon, having no atmosphere, no oceans, and no continental drift, has retained all this evidence for us to observe.
The last Soviet lunar probe, Luna 24, delivered samples of soil back to Earth in August 1976. The next time a spacecraft was sent to the moon was only in 1990. It was a Japanese satellite. Then, in the 90s, only 2 American planetary probes were launched into lunar orbit. It seemed interest in the moon was on the wane.
The rivalry between the two superpowers in space allowed us to enrich significantly our knowledge about space in general and about the solar system. We learned a lot about the nature of the planets. However, at that time, we were not yet ready to explore the moon. It was too expensive. In addition, the main goal was to demonstrate one's capabilities to the potential adversary and not to colonize the moon. But now, in the new millennium, things have changed.
Humanity is once again looking towards the moon, or rather its resources. Today, we obviously need more and more minerals because the population of the planet is constantly growing, which means that its needs are increasing. The chemical analysis of the moon's soil, made back in the 1970s, showed that it is rich in refractory elements such as titanium and aluminum.
Если на Луне выкопать, ну, с футбол...
If you dig out an area equal to a football field, then you can find titanium, iron, calcium, potassium, and so on.
В общем, все. Конечно, не
But, of course, the point is not exporting them to Earth.
производить это на Землю, а для того, чтобы строить лунную базу.
In order to build a lunar base, all of these minerals will be needed.
Ископаемые.
But the main treasure of the moon is helium-3. This is a very rare and expensive isotope. Scientists believe that helium-3 can be used in the future in fusion reactors. In fact, it could be a new source of energy for us.
Его
There's plenty of it there. We could use it for 1,000 years or even more. The energy problem could be solved for our civilization for the next 1,000 years. Of course, in 1,000 years, we'll come up with something else.
According to scientists, to provide energy to the entire population of the Earth for 1 year takes about 30 tons of helium-3. According to the most conservative calculations, the moon has about 500,000 tons of the isotope, and it lies just below the surface in the lunar sand, the regolith.
добыча гелия-3 на
Extracting helium-3 on the moon would be like harvesting crops.
такой же комбайн,
A similar machine could be harvesting the surface of the moon. The helium-3 is located within the first 3 meters.
насыщенный этим гелием-3.
In addition to the relative availability of helium-3, it has another obvious advantage. When it is used, no radioactive waste is generated, so there will be no problem of its disposal, like the one which must be solved here on Earth due to the operation of nuclear power plants.
However, it is still too early to talk about fusion energy. Scientists haven't found a way to control thermonuclear reactions, which means that the reactors have not been created. And so, helium-3 as a fuel is of no use either. Thermonuclear energy is only a promising direction. Most likely, this problem will be solved in this millennium, together with another equally challenging task, the colonization of the moon.
Similar projects have been in the process of development in both Russia and in the United States since the middle of the last century. However, in the 70s, it became clear that no country could do it on its own. The Russian program for the colonization of the moon, called Zvezda or STAR, was shut down. America also failed to bring its plans to fruition due to their high costs.
Actually, both the Americans and the Russians lost their motivation because, after all, colonizing the moon is rather expensive.
But now the situation is changing. New technologies are emerging, and the colonization of the moon does not seem such an overwhelming task.
I think that the issues here will be purely financial, most likely, and not technological. Technically, if we start to pursue this idea, the question might arise, is it worth spending money on it now or not?
In 2017, at the Institute of Biomedical Problems in Moscow, 6 people, men and women, participated in a simulated flight to the moon. They spent 17 days in a ground test module. According to the simulation, during this time, the astronauts were to have flown to the moon, flown around it, and returned to Earth. The main goal of the experiment was to work out how members of a mixed-gender crew interact with each other. Probably in the near future, it is such mixed-gender teams that will inhabit the first lunar bases. Similar training is being conducted in other countries.
For the time being, each of these countries is developing its own program and conducting it alone. But most of them are ready to collaborate in some specific experiments in the near future. Well, except some big countries, for instance, China. They are conducting their own research and don't want to share it with anyone else. And the USA is collaborating only with Europe because NASA and the EU have strong ties.
In recent years, enterprises of the Russian rocket and space industry have also begun active work on the creation of new spacecraft for flights to the moon. Engineers are working to create a new probe to be called Luna 25. It is planned to be launched to the moon in 2019. The main task of the spacecraft will be to work out the technology of a soft landing in the near polar region of the moon. No one has yet landed there, but the moon poles are the most promising for research and possible exploration. After all, scientists think reserves of water in the form of ice are located there.
No one knows who will build the first inhabited bases on the moon and when, but this is unlikely to happen soon. For example, the Japanese do not intend to send their astronauts to the moon at all. They will probably be replaced by robots.
And there will be no need to create special conditions for them. NASA is also seriously discussing the option of robots, which will be controlled from Earth. Despite all the ambitious plans, the question of the need for a person to stay permanently on the moon remains debated.
It is possible to observe the moon from unmanned probes. Actually, many discoveries on the moon and maps of the surface with an accuracy of up to 3 feet were made with the help of these probes, and research could be continued in this way quite successfully.
But why build inhabited or uninhabited bases on the moon? Scientists suggest that they can be used as scientific stations for collecting material and observing space.
We do not fully understand the effects of cosmic radiation on living beings, on humans, not only in the sense of radiation's direct effects, but also in terms of, for example, what effect it has on memory, on the brain, or on the ability to make decisions. And the moon could be the biomedical center for studying those questions. You could, for example, send some sort of colony of simple organisms there, then bring them back to Earth, laboratories, and investigate genetic or some other changes.
Space agencies of different countries view the moon in the future as a transit point for flights to other planets. Such theoretical projects exist already.
Gravity on the moon is 6 times weaker than the Earth's, and therefore, it would be much cheaper to launch a rocket to Mars from there, since less fuel will be needed.
But to do this, we will need to build a launch pad on the moon, and hence the base for the employees of the Lunar Spaceport with everything necessary to sustain life. Such a manned base could also be used for commercial purposes. Space tourists from Earth could stay there. Perhaps one day it will be possible to buy a ticket to the moon, just like now we can buy a ticket to some exotic islands. In any case, enterprising Americans are already looking for volunteers to visit Earth's natural satellite. However, how realistic is it to make the moon suitable for life? It is one thing to walk on its surface, but staying there for a couple of days is totally different.
Although a person can live on the International Space Station for a year or more, on a moon station, the crew would need to be changed once a month. Otherwise, they would have to be treated for radiation sickness.
Calculations show that an astronaut, after 100 hours on the moon, will receive a dose of radiation that is dangerous to health. And in case of a solar flare, this could happen in a matter of minutes. Therefore, experts say that it's preferable to live under its surface, not above.
The moon's surface is made of very durable material from basalt. Basalt is so strong that you make tunnels inside it. You won't need any structural reinforcing to support them. Simply put, you dig a tunnel and live in it.
Moreover, under the surface of the moon, we can use basalt to extract oxygen, which is so vital for human life.
The basalt consists of silicon dioxide and metal oxides in almost equal proportions.
And therefore, if we squeeze oxygen out of the basalt, then along the way, we'll also get iron, titanium, manganese, and magnesium. So it's an entire array of different metals that will be available to us.
On Earth, one of the main requirements for life is water. And today, we know that the moon has it.
Launched in 1994, an American spacecraft named Clementine had a neutron sensor, which showed some anomalies that could indicate the presence of water. After that, the U.S. launched Lunar Prospector. This was a scientific satellite which confirmed, indeed, the presence of water.
Scientists claim that water is contained at the bottom of the lunar craters in the form of ice stocks, but nobody knows how much water they contain. Despite all our modern technology, mankind is not yet ready for the full-scale colonization of the lunar surface. Much remains to be understood and calculated, and the pros and cons still need to be weighed. Therefore, experts believe that the current moon race will not be as intense as the first one, because today there is no fierce rivalry, and the pioneers long ago accomplished their goals. At the end of the 19th century, scientists assumed that there was a developed civilization on Mars, similar to ours. Giovanni Schiaparelli from Italy noticed straight, long lines on the surface of the red planet through a telescope and thought they were man-made channels. Later, the astronomer Percival Lowell suggested that a Martian civilization had built an extensive network of aqueducts to deliver water to its settlements from the polar caps of the planet. It is no wonder that, given such a point of view by science, the radio adaptation of H.G. Wells' War of the Worlds, in which the author describes how Martians conquer Earth, caused a real panic among many listeners in the U.S. They seriously thought that Mars was attacking.
At the beginning of the 20th century, the existence of the Martians was considered almost a proven fact. People were afraid that their highly developed civilization would one day attack Earth. And only in 1965, when NASA sent the Mariner 4 spacecraft to Mars, was the truth revealed to the world.
The pictures taken by Mariner 4 showed that Mars was a cold and deserted planet. It also turned out that the planet's atmosphere consists of poisonous carbon dioxide. It became clear that life similar to that on Earth couldn't exist in such conditions.
I think that we inherited our interest in Mars from previous generations, when they still did not know about the hazards of space, and when they thought Earth was the sister of Mars, with its own civilization and its own history.
Today, we have come far in our scientific understanding of Mars and realize that there's nothing there close to what we dreamed of.
But why do the leading space powers spend billions of dollars to study the red planet? Why do they keep sending new spacecraft there? And even want to send people to Mars?
Mars is the key to one of the main mysteries of space. Is there life on other planets? If we find at least primitive bacteria on Mars, then life should be spread across the universe. Then, according to probability theory, in one of the hundreds of billions of stars in our galaxy, there should be a planet inhabited by intelligent beings. But is life possible on Mars at all? And where can we find it? These questions still remain unanswered.
Could there be at least primitive life in the form of microbes and bacteria on Mars? Perhaps the answer to this question should be sought not in the present, but in the distant past. Now, the average temperature on the planet is minus 76 Fahrenheit.
At the polar caps, it gets as low as minus 87 Fahrenheit. A temperature above zero can be found only at the equator areas and for a very short time. Really, just for a few hours. So, it reaches 30 to 50 degrees, but doesn't stay that way for long. In general, the temperature is always below zero. Now, water in its liquid state simply cannot exist there because the pressure is very low. The average pressure is only 6 millibars.
But 3.5 billion years ago, Mars could have had liquid water and an atmosphere of oxygen. The specific red color of the soil indicates a high content of iron oxide in it. Soils of the Martian type are quite common on Earth too. They are formed only in a warm, humid climate.
There are a lot of volcanoes on Mars, including the giant volcano Olympus, over 69,000 feet high. There is a huge difference between the highest and lowest points on Mars. The crater Hellas is almost 26,000 feet deep. The volcanoes, of course, had eruptions in the past and could have created the conditions for some kind of primitive life.
Scientists believe that the presence of heat, water, and iron oxides could trigger the birth of life on Earth. But was ancient Mars like Earth? In 1976, the Viking space probe first obtained high-quality color photographs of the surface of the red planet. The orbital modules found relief details, very reminiscent of traces of water erosion, including dry riverbeds.
And if there were rivers, then there is some hope that there were other forms of life. Where there is water, there is likely to be life. We know that life exists in Antarctica, where there is at least a drop of water. In a desert that has rain only every 5 years, there's also life. That is, water is the basis of life.
NASA's Mars rovers, Spirit and Opportunity, found minerals that could be formed only as a result of prolonged exposure to water, and the rover Curiosity found dried ancient lakes with clay at the bottom.
Clay minerals, so-called phyllosilicates, were found that indicated there was a kind of silt that usually appears at the bottom of a lake, in which something could live.
From a chemical point of view, life on Mars is possible. NASA's probes have found all the elements necessary for its occurrence on the surface of the planet.
Basically, all the necessary conditions were present at that moment. If not to create life, then at least to support life. Firstly, there was water. Secondly, all the elements which are considered important for life were found. For example, carbon, nitrogen, phosphorus, oxygen, and hydrogen. They found that basically, bacteria could have a lot to eat.
In the pictures taken by the Mars rover Curiosity in 2012, geobiologist Nora Nofke discovered objects similar to cyanobacterial mats. They're deposits of limestone or dolomite, which in terrestrial conditions are formed only as a result of the activity of living organisms. She suggested that these objects had appeared on Mars for exactly the same reason they did on Earth. But this is just a hypothesis. To confirm it or disprove it, a chemical analysis is needed, which means you need to send a whole scientific expedition to Mars. For now, that's unrealistic. But the red planet does send us fossils. They literally fall from the sky. Scientists have already discovered 34 Martian meteorites.
Some large bodies hit Mars and the Moon, ejected material, and some of it flew off the planet. There's less gravity to hold it back. The gravity on Mars is approximately 1.5 times weaker than on Earth. These meteorites flew through space and then fell on Earth.
The most famous of them, ALH 84001, was found in 1984 in the Antarctic ice sheet.
It turned out that there is a way to search systematically for meteorites, and their best source is Antarctica. You go out on a 2-mile glacier and take a metal detector or an ultrasound probe. Since meteorites are made of stone, any body found in the ice, any rock, is a meteorite. There are no other stones there. All other stones are 2 miles below the surface. Scientists are actively conducting such searches, and the number of meteorites being found is 10 times larger than we had known before.
Isotopic dating has shown that the age of the meteorites is 4 billion years. It was during this period, according to scientists, that there could have been a warm and humid climate on Mars and life. Thorough analysis has been carried out on these objects, and in August 1996, a sensational article was published in the journal Science. Microscopic fossils resembling bacterial colonies were discovered on meteorite ALH 84001.
It was so sensational that they called U.S. President Clinton to tell him that they had found life, and then he made a statement. As far as I understand, they found fossils that could be thought of as bacteria fossils, but we've never found similar fossils on Earth. In such cases, people always begin to argue about what it is that was actually found. You know, it's like the question, do you believe in God? Some say I do, others say I don't. It's impossible to prove scientifically whether God exists or not.
Many scientists were skeptical about the results of these studies.
They noted that the size of the formations found in the Martian meteorite is 100 to 1,000 times smaller than typical terrestrial bacteria. It is almost impossible to place DNA or RNA molecules in such a volume. As usual, scientists have different opinions, but there's still hope of finding life on Mars.
On the other hand, meteorites may be the reason why spacecraft haven't found life on Mars yet. Perhaps a collision with a large asteroid or a comet turned the once warm and humid planet into an icy desert, and at the same time destroyed all traces of life that had ever existed on the planet.
When a projectile hits an area, an explosion occurs, and this explosion destroys everything around it. If a celestial body struck Mars, it could have destroyed the whole atmosphere.
And if there's no dense atmosphere, water can't exist in liquid form.
Astronomers suggest that the Utopia Plain on Mars is the largest meteorite crater on any of the planets in the solar system. It's 2,050 miles in diameter. It's a huge basin in the northern hemisphere of Mars, which was created after an asteroid at least 600 miles across hit the planet. A catastrophe of such magnitude is supposed to have changed the appearance of the planet dramatically.
A monstrous collision could have even made the planet's core stop rotating. Perhaps because of this, Mars has almost completely lost the magnetic field that protects the planet from the destructive effects of the solar wind and radiation.
The solar wind interacts with the atmosphere and, as a result, removes oxygen from the atmosphere. And hydrogen also disappears.
Solar radiation passes through the thin and rarefied atmosphere of Mars unhindered. Its level isn't just high, it's deadly. That's why the planet basically can't have any flora or fauna. Scientists' only hope is extremophiles. On Earth, they managed to survive inside atomic reactors and in aggressive acids. In 2004, the probe Opportunity recovered the mineral jarosite, which is a potassium and iron sulfate from Mars. A century and a half before, the same mineral had been found in Spain. Such a mineral can be synthesized only in water containing acid and iron. In Spain, there is a river that contains both in abundance. This is the Rio Tinto, or Red River.
It was believed that there could be no life in the waters of the Rio Tinto, which contains a weak solution of sulfuric acid. But only recently, scientists have discovered that the river is teeming with microorganisms, and the red color of its water is due to the fact that bacteria can eat iron, or more precisely, oxidize it. If there is some kind of life on Mars, it may resemble that which thrives in the Rio Tinto. However, the temperature on the red planet is far lower than in sunny Spain. Yet, extremely cold temperatures are no problem for bacteria. After all, some of them can even survive in the permafrost.
At the end of 2012, Russian and American biologists published the study results of extremophile bacteria strains they found in 130-foot wells on the Taimyr Peninsula. Scientists have placed them in artificially recreated Martian conditions. The bacterial strains survived and continued to grow and multiply, albeit at a very slow rate.
However, extremophile bacteria have not been detected on the surface of Mars by spacecraft. But maybe we are looking in the wrong place. Maybe we should dig deeper. It is soil that could protect Martian life from the murderously cold weather and cosmic radiation.
In 2008, a NASA probe called Phoenix successfully landed near the North Pole of Mars. Scraping off only a few inches of the Martian soil, the scoop of the Phoenix's mechanical arm pressed against ice. Further analysis showed that this is not frozen carbon dioxide, but water similar to that on Earth. So underground glaciers were discovered on Mars.
There is a lot of ice, even under the surface. The probe Mars Odyssey carried an instrument developed by the Space Research Institute, which determined the presence of hydrogen at different depths and showed that, indeed, there are huge deposits of ice.
If we assume that the Martian glaciers are heated by geysers from below, then there must be groundwater, warm underground rivers in which microorganisms can live. After all, on Earth, if there is heat and water, then in 100% of cases, life exists there. And in 2011, some hope appeared. The Orbiter spacecraft detected flows hundreds of feet in length along the walls of craters in the area of the southern hemisphere of Mars. It is hypothesized that this could be groundwater.
Water cannot exist on the surface, but it could exist somewhere underground and sometimes break through the ground under pressure. The same thing happens on Earth.
But not all scientists agree with the assumption of the existence of groundwater. A number of scientific works assert that these are flows of certain brines and acids. There's even an opinion that liquid is not flowing along the slopes of the craters at all.
В настоящее время, в летний
Now, during the Martian summer,
какой-то
there's some kind of flow, but recent studies have shown that it is not water, but only sand that is moving.
песок движется. Просто песок движется.
Is it sand, salt, acid, or is it water? We will know only when a spacecraft lands in the immediate vicinity of the mysterious streams. In any case, there is a chance for the discovery of life. After all, methane has been discovered in the atmosphere of Mars. On Earth, it's often living organisms that produce this gas.
It is still there, but it changes depending on the season. But it is at very low levels. And now the TGO orbiter has been launched as a part of the ExoMars program. It includes an instrument developed at a Russian institute. It has a high level of sensitivity to methane. The orbiter will attempt to map the planet's methane.
If there is methane in groundwater on Mars, is there primitive life as well? To find out this task of future missions, not only for NASA, but also the European Space Agency and the Russian Space Agency are preparing to launch new spacecraft. In 2020, as part of the ExoMars project, a Russian surface platform with a European rover on board is planned to be launched.
The rover was made in Europe, but it will carry two instruments made in Russia. One will be engaged in infrared spectrometry. This will allow us to study and explore samples' mineral composition. The second instrument will be used to look at the content of any subsurface water. For that purpose, a drilling device that can reach 7 feet will be installed on this Mars rover.
Prior to this, the most advanced drilling device was installed on the Curiosity rover, which allowed for drilling only 4 inches into the ground.
Plus, the platform itself will carry a fairly large range of Russian instruments under development. It will be designed to be stationary, but nevertheless will allow exploring any nearby area. And there will be a separate instrument to research that area. These are positive developments for Russia's part in the scientific investigation of Mars.
The USA is also going to launch a new rover in 2020. Planners of future missions want to collect information about the possibility of building a habitable base on the surface of the red planet.
Most likely, the search for life on Mars is not going to end with success. But maybe, in time, people themselves will be able to populate the red planet. Hollywood films have taught us that colonies on Mars are something that might happen in the near future. NASA, the European Space Agency, Russia's space agency have announced plans for manned flights to Mars in the 2030s. But is it realistic?
The Mars 500 project was created by the Medical and Biological Institute of the Russian Academy of Sciences. During the experiment, 6 volunteers stayed in a closed complex for 519 days. The experiment was as close as possible to a real manned flight to Mars, which simulated walking on the planet while wearing spacesuits and then returning to Earth. In laboratory conditions, the mission was completed successfully, but scientists are concerned that under real conditions, astronauts will not be able to fly to Mars.
During the period which is required for a flight to Mars, people will actually accumulate a lethal dose of radiation. And the Institute of Biological Problems is experimenting with comparable doses of radiation on animals. The experiments show that changes occur even in the animal's brain activity under such a large amount of radiation. That is, going to Mars is not even a one-way ticket. The mission is practically a failure before it even starts.
The Earth's magnetic field protects astronauts in orbit from radioactive rays that exist in outer space. They can destroy tissue and lead to cellular mutations. The construction of spacecraft reduces the dose of radiation, but not enough. engineers still have a lot of work to do in order to reduce it further. With the advent of new materials, there should be a solution to the problem.
The second difficulty is weightlessness. After such a long stay, even with exercise machines on board, the main muscle groups atrophy, which would be irreversible. In other words, flying to Mars poses many difficulties right now. I'm sure that in the future, astronauts will be able to survive a flight to Mars. But once on Mars, they will be in extremely hostile conditions. Astronauts will face the same dangers as there are in open space. When American astronauts flew to the moon, they were lucky that the sun was calm. But if on the way, would-be conquerors of Mars were exposed to streams of high-energy solar protons, then most likely they would die from acute radiation sickness.
Astronauts could hide underground on Mars to protect themselves from radiation, but there is still another danger.
Mars has very thin air and an unpredictable surface. And when sandstorms begin in the conditions of a thin atmosphere, the surface features can't be seen through them. In other words, it is similar to a dust storm, which makes it difficult to fly through. And everything under it most likely would be frozen ground. This is like permafrost on Earth. Frozen sand mixed with water. If we build something and live there, we would release heat, which would melt the ground, and everything would fall apart. So there are a bunch of rather challenging problems to solve if we want to construct something on Mars.
Nevertheless, there are optimistic scientists who are confident that all these problems can be solved.
For now, the biggest problem is radiation, because I think we can develop technologies to produce fuel, water, and oxygen to breathe. The 2015 film, The Martian, essentially isn't that far from reality. Perhaps in 10 or 20 years, a human being could fly to Mars, but it's hard to say how long he could stay there.
It is surprising that with existing technologies we cannot land on Mars, but we could try to transform it into a second Earth. The head of SpaceX, the American businessman Elon Musk, has already presented his plan for the terraforming and subsequent colonization of the Red Planet.
Terraforming is, in fact, a transformation of a planet on which there is no life, so that people can live there.
The first plan of Elon Musk's plan is simple and even doable using modern technology. It involves detonating nuclear bombs at the planet's ice caps. Water and carbon dioxide would evaporate and form an atmosphere, and a greenhouse effect would begin. Russia's scientists also have ambitious projects. They argue that it is much cheaper to capture asteroids using spacecraft and send them to the Martian poles. In this case, the amount of heat emitted would be thousands of times bigger than during nuclear explosions.
It's possible. The Japanese have taken the first step. They sent a spacecraft called Hayabusa to a small asteroid named Itokawa. Not only did it fly there, it landed on the surface of the little asteroid after many years of flying. Then this small device returned to Earth, bringing samples collected there. So the technology we have now is very well developed, and there is no reason to doubt that such a plan is feasible.
In the 21st century, humanity is likely to learn how to change the orbits of asteroids, and perhaps Mars will undergo a new meteorite bombardment. There are plans to create a shield around the planet to protect against destructive radiation. The American scientist Jim Green proposed making a huge planet-sized conductive metal screen and deploying it in space near Mars. It would be supplied by powerful nuclear power plants and used to generate an artificial magnetic field. Today, with the help of orbital telescopes, scientists discover, observe, and study planets that are in other star systems.
The sun is our native star. We call it the parent star of our solar system. There are other parent stars or just stars in the universe. Some of them are close to us, others far away. And planets rotate around them. These planets are called exoplanets.
Can these planets have the conditions which are at least in some ways similar to those on Earth?
Planets with the size of Earth are generally on the verge of being detected with the help of modern methods. Therefore, when we say that an Earth-like planet has been discovered, it usually turns out to be a planet 5, 3, 2 times larger than the Earth in size. Well, their masses are different as well. But lately, planets whose dimensions are very close to Earth, or maybe slightly bigger, have been actually discovered. That's where the phrase, Earth's sister planet, comes from. It's difficult to say with certainty what is on their surface. In what state their atmosphere is, what conditions are like, and if they are somehow similar to Earth.
Scientists have identified several parameters, according to which exoplanets can be considered potentially habitable. One of the main criteria is the so-called habitable zone.
The habitable zone is the climatic zone where the planet is located, where water may exist in liquid state. This is the first condition. The second condition is that the planet shouldn't be a gas giant. It must be a solid planet with an atmosphere.
However, within the same habitable zone, there may be completely different planets, with totally different conditions on their surface. And the examples are not so far to seek. Our solar system has planets of the so-called terrestrial group: Venus, Earth, Mars. There are several of them, but only one has life on it. There's Mars, which has no atmosphere and no liquid water. And there is Venus, which has the same illuminance from the sun, but the greenhouse effect is different. So the question of habitable zones is still up in the air. This is just some approximation of where we would like to find and try to find habitable planets.
According to some data, there may be up to 2 million exoplanets in the neighboring star systems only in our Milky Way galaxy. We just can't see those planets, even with the help of modern telescopes.
Now, when we look at a starry sky, we see only those stars that shine with white and yellow light, to which our eye is well adapted. There are much more so-called brown dwarfs, which are very dim and poorly visible. But these brown dwarfs might also have planetary systems around them. Now we have just set these tasks, and just now we are developing special infrared telescopes that can see such dim, almost non-luminous stars in space.
Today, the existence of several dozen of those planets which resemble Earth in some way or another has been confirmed. However, they still bear the title of potentially habitable planets.
There are several planets resembling Earth. That is, they are 2 to 3 times bigger than ours, and therefore probably 5 to 7 times heavier. They are in the zones where water can exist in liquid state. We still don't know whether there is some water or if the atmosphere contains oxygen. Space projects are being prepared for observations that can figure that out.
So far, no scientist has decided to name any of the potentially inhabitable planets discovered as second Earth that is suitable not just for microorganisms, but for people to live there as well.
We can't say if there is any possibility of water being on the planets. We can determine the pressure on the terrestrial planets, but not on gas giants. And the temperature, which varies between 30 and 200 degrees Fahrenheit.
If there was water, life forms like those on Earth could exist there. We can't say if life can thrive in such places, but if we went, just maybe, it would turn out that we can survive there.
Though reports on new so-called Earth sister planets appear regularly in the media claiming they are like two peas in a pod, scientists argue that they haven't found such a planet yet, but they keep looking.
No scientist will ever agree to support this statement wholly without any remarks. But journalists ignore this and go for the sensational parts instead. Hope is a hard habit to break. I would like to believe that one of these planets is similar to Earth.
We can't say that we found a planet totally like Earth, but planets similar to Venus have already been discovered.
But even if we find Earth's twin planet, reaching it is in the distant future. Since the nearest star systems which might have similar planets aren't measured in miles, but in light years. Even 1 light year is nothing compared to the universe, but it is insurmountable for us.
We assume that the nearest star, which is 1.33 parsecs, or 4 light years away from us, has planetary systems, and it's quite possible that there is a planet rotating around the third brightest star in the galaxy. And Proxima Centauri, the central star, might also have planets in its orbit.
Flying to faraway stars and galaxies is a very distant prospect, but there are potentially habitable places which are much closer in our solar system, not far from Earth. 2 more planets are in the habitable zone, Venus and Mars. But can they ever become a new home for people? Humanity has always been interested in Mars. It is the planet that is considered to be the nearest cosmic body where, according to scientists, life possibly existed in the past, although today, life is unlikely to be found there.
Mars has a very weak atmosphere. We can assume that it is almost non-existent. Mars has a high level of radiation and it is very cold. The temperature is mostly below zero and raises above zero only in the equatorial areas during summer.
But with all the drawbacks, Mars has one unconditional advantage, the presence of water below the surface. This was confirmed in data obtained by U.S. spacecraft. It is this fact that today continues to fuel the interest of mankind in Mars. People have been preparing for a flight to the Red Planet for several years. This footage is the beginning of a unique experiment, Mars 500. A group of astronauts must make the longest journey in the history of mankind. However, it's not real. After all, this is only an imitation of a space odyssey in terrestrial conditions. In 2020, at the Institute of Biomedical Problems, it was decided to check whether a person can withstand a flight that would last 500 days.
Russian cosmonaut Valery Polyakov holds a record in this regard. He spent more than a year, or 437 days to be more precise, on board the Mir orbital station. Not so long ago, a new record was set by the crew of the ISS, which included Mikhail Kornienko, a Russian astronaut, and Scott Kelly, a NASA astronaut, who spent 340 days in space. So, a 500-day mission should be possible.
However, we should not forget that unlike the astronauts working on the ISS, the explorers of Mars will not be able to return to Earth in case of an emergency situation, and even just keeping in touch with the ship will be very difficult, so far from our home planet.
Of course, any flight is a combination of the autopilot and manual control, which is not implemented all the time. The craft isn't always in sight. You have to wait for communication to be restored and face connection delays.
However, the main reason why a mission to Mars is not yet possible is cosmic radiation. Today, there's no protection from it. Even if the astronauts manage to fly safely to Mars and land on it, they can't stay there long. they will have to seek or build a shelter from radiation and dangerous asteroids.
If we figure out how to deal with the radiation sickness, we'll be able to set up domes, pump water into them, raise the temperature, in other words, to do everything we've already seen in various science fiction films. Science fiction is quite a successful way of predicting the future in a number of fields.
However, there is another option: to try and change the Martian conditions so that the desert surface becomes blooming and habitable. But is that really possible?
This is the fruit of the unthinkable imagination of science fiction writers. Let's create a new atmosphere on Mars. Let's create conditions similar to Earth in this atmosphere. Let there be more greenhouse gases. It will be warmer. Let there be oxygen, so that we could go there without spacesuits and so on. This kind of transformation is called terraforming.
Some experts suggest, for example, starting to bomb the planet with nuclear charges or comets. Dust will then create a greenhouse effect for some time, and the planet will begin to heat up. Meantime, plants can be made and introduced for the production of carbon dioxide, which will fill the weak atmosphere. Then, photosynthetic bacteria will be launched into it so that they fill the Martian sky with oxygen. But most scientists are skeptical of such ideas. After all, Mars does not have a magnetic field that can hold atmosphere. It will just disappear.
I can't imagine how Mars could be altered to be more like Earth, because its atmosphere will evaporate into space. It's not really possible to extract oxygen and other gases from the soil, and in any case, Mars will remain a cold planet if we don't come up with any new technical solutions. People won't be able to live without protective devices in the Martian environment in the foreseeable future.
Therefore, some scientists are urging us to pay attention to another planet in the solar system, Venus, because it already has a powerful atmosphere and does not need to be recreated.
Там давление практически около 100 атмосфер.
The pressure there is almost about 100 atmospheres. The temperature is so high that some low melting point metals, such as tin and lead, melt fast. The atmosphere consists mostly of sulfuric acid vapors. And all in all, the conditions are harsh, even for spacecraft.
In other words, Venus is just a hell, where even metals melt under normal conditions and the pressure is as huge as under a mile-deep ocean. The first research vehicles that arrived on this planet were simply crushed by its atmosphere.
The first spacecraft didn't have an enviable fate, but we must pay tribute to the Soviet Union, the only successful nation to land their Venera probes on the surface, receive images from there, and study the real climate on Venus. Some questions were left unanswered, but they cast light on many of them. Foreign agencies, the Americans, and others have failed so far in these missions. They haven't achieved the same success yet, as it was the success of the Soviet technology.
And yet, researchers have made bold assumptions about how to reduce the greenhouse effect on Venus so that the planet becomes cooler and more oxygenated. This can be achieved by photosynthetic microorganisms or protozoa.
For example, at an altitude of 40 miles above the surface of Venus, the pressure of the atmosphere is approximately 1 to 2 of the Earth's atmosphere, and the temperature is 70 degrees above zero. We can launch some volatile plants, maybe even microscopic ones, such as algae or bacteria, and they will absorb carbon dioxide and cause precipitation in some stable form. If we change its atmosphere, we will remove all carbon dioxide from it. The temperature there will be about 120 degrees above zero.
It is as hot as in some deserts on Earth, but quite bearable. However, the process of terraforming Mars or Venus is not quick at all. Such a full repair of the planet might take hundreds or even thousands of years. In addition, the delivery of necessary goods and equipment will be very expensive.
One flight to Mars will last more than 1.5 years. It's long and expensive, but since the prospect of colonizing even neighboring planets is very vague, then maybe it's worth looking for new territories even closer. Nowadays, more and more scientists are suggesting the moon is an object for colonization.
One flight taking crew or delivering space cargo to the ISS costs an astronomical amount of money. Maintaining the station's performance is very expensive too. That is why the leading space powers once decided to work in near-Earth orbit together. But nobody has ever estimated the cost of colonization of the nearest planets. We emit more and more heat, begin to warm up our planet, and have already developed so much that we are starting to spoil our natural environment. So in 100, 200, 300 years, let's take it all to our backyard, the moon, so that it all works there, so to speak. Grams of some useful substances are produced, and the sun will bring large amounts of energy. Environmentalists will also profit from this in the future.
Humanity already has the experience of flying to our planet's satellite. Besides, there are water reserves on the moon, and whole cities can be built under its surface in thick layers of basalt rock.
We can construct a system of buildings that reach 1,000 floors high on the moon. And as far as energy is concerned, the sun will provide us with its energy for at least several tens of thousands of years. We can get oxygen in large quantities from mini comets that are now flying past Earth. They can be intercepted, delivered there. Each snow block, like the one that fell in Chelyabinsk, weighs 1 million tons. It's huge.
One solution being proposed to solve the problem of delivering all the necessary cargo to the moon is to build a space elevator. It will run between Earth and its satellite on a thin cable of nanocarbon fiber, which is much stronger than steel.
A cable of this fiber, 1/20th of an inch thick, can hold a 5-ton load. If we drop such a cable from the center of the moon faces Earth with one side. This cable will not be wound around the moon. It will hang under the force of gravity, directed right to the center of Earth. If this cable is covered with a thin film of superconductor, then it will be possible to move along it, using a magnetic field to rely on it without friction.
It's thought that it will be so quick that the elevator will take us from Earth to the moon in just 3 or 4 hours. It would allow us to transport everything we need to construct a habitable space on the moon in the shortest time possible.
Using ion engines, you can easily send some cargo to the moon, even if it takes a long time. There would be no need to build a large heavy rocket to deliver it there. If it is profitable and we manage to do it, then the idea might come to life.
In addition, the elevator will help us dispose of lunar and terrestrial waste that can be thrown into the sun while the cabin is moving.
After all, if we accelerate the cabin along the elevator cables, we can reach speeds of, say, 20 miles per second. This is the speed of Earth moving around the sun. And at this speed, we will be able to release the cabin off the elevator. Having already lost its orbital velocity around the sun, and under the influence of the sun's gravitational forces, it simply falls towards it. And if we fill this cabin with all sorts of radioactive waste, it will burn away. The sun is like a nuclear oven that can burn it all.
Transport links between the moon and Earth are a very popular discussion point between various specialists. However, so far these are only projects on paper, and it's still difficult to say when, if ever, they will be implemented.
It has been physically calculated, but it's still not clear how to make such a cable. But we're smart. With the right funding, there is always a way. The question is more whether it's time to invest.
At the end of the 20th century, scientists discovered extremophilic microorganisms that can survive at temperatures up to 250 degrees in volcanoes, in geysers, on the ocean floor, and in permafrost. It turned out that many terrestrial organisms do not need oxygen or sunlight to exist.
We all need organic compounds and organic materials. We extract energy and oxygen from them in order to oxidize these substrates. But some microbes can use inorganic energy sources such as hydrogen, hydrogen sulfide, and ammonium. And they can also use other oxidants in addition to oxygen, carbonic acid, oxidized iron, for example, or sulfate. There are many combinations of energy source and oxidizer.
It was these discoveries in the field of microbiology that once again made scientists start an active search for signs of life on other planets of the solar system, their moons, and even comets.
Amino acids are found in comets. In other words, these are complex compounds. Sometimes they are called pre-biological. There are not just a lot of them in space. They're found in huge quantities. It's really surprising that there are so many of them. It is obvious that the protoplanetary cloud, which formed our planetary system, our Earth, had all these elements.
Moreover, living organisms were found on the outside of the ISS. That is, they managed to survive in outer space. Most likely, they were brought from the stratosphere along with dust and ascending air currents. But a number of scientists argue that some microorganisms found on the ISS may be of extraterrestrial origin. That is, they exist in interplanetary cosmic dust.
The LIMP experiment, which will be conducted together with the Russian Space Research Institute, will be able to answer these questions because it involves taking a device out of the station and using it to collect the dust, which will allow us to analyze it in greater detail.
All these discoveries indirectly confirm the panspermia hypothesis that life was brought to Earth by asteroids and comets. But can microorganisms survive the dense layers of the atmosphere when asteroids pass through them? To answer this question, Russian scientists decided to conduct two experiments, the Photon M and the Bion M1, whose purpose was to create artificial meteorites with various microorganisms on board.
We took a specially polished piece of basalt that resembles a tram wheel. Why? Because it has 25 holes with an average depth of up to 0.27 to 0.31 inches, where we can place various microorganisms, thus imitating crevices. They are similar to crevices on meteorites which occasionally fall to Earth. Microorganisms have a better chance at surviving in crevices than on the surface.
As a part of the experiment, artificial meteorites were launched into Earth's orbit in such a way that they rotate for 2 weeks and then fall under the influence of our planet's gravity. During the experiment, Photon and Bion passed through the dense layers of the atmosphere where they were heated to 1800 degrees Fahrenheit. The basalt melted from the heat and almost all of the microorganisms burned up. However, 2 types of extremophilic bacteria still managed to survive. So it is quite possible that life is spread across the solar system. But it develops only where the soil is suitable, for example, on Mars. Since the average temperature on the planet is minus 76 degrees, the Martian soil is very similar to permafrost in its properties. This means that cryopegs can exist in it. These are bacteria that can survive at extremely low temperature.
An article was published some time ago, in 2010, I believe, in the prestigious American scientific journal PNAS. It stated that microorganisms had been found in the ice of the Kolyma River in the north of Russia. They turned out to be Corynebacteria, which are perfectly resistant to the rarefied atmosphere of Mars. And what's more, they grow better there than under normal conditions.
However, even primitive life on Mars has not yet been discovered, but perhaps we need not go so far to search for it. After all, water, which is essential for the emergence of life, is found even on the moon.
The moon also has permafrost at the poles, and if life appeared on Earth due to collision with comets and other celestial bodies that produced cosmic spores, they could just as well be preserved in the natural refrigerator of the lunar poles. Therefore, by studying the lunar poles, we can, in fact, understand what was brought to Earth billions of years ago. But of course, no one talks about any form of life on the ancient moon or on the modern moon, because the environment is not suitable. In fact, it's just open space, so anything similar to earthly life can't exist there. It might be in a preserved form, but it can't have originated there.
The modern Russian lunar program involves the creation of a base on the surface of the moon. Astronauts will need to be provided with water. According to the plans of the Russian Space Agency, lunar ice will be obtained and delivered to Earth in 2025. This will greatly facilitate the task of scientists.
The sensors installed on the American Viking-type spacecraft, which explored Mars from 1976 to 1980, did not find any life forms in the soil of the Red Planet, but they did not find life on Earth in the rocky deserts of Antarctica. Of course, now technology has advanced a lot, but no automation can replace a full-fledged laboratory analysis on Earth. No wonder American space exploration is concentrating on the delivery of soil samples from Mars. But strangely enough, a real surprise might be presented to the scientific world not by Mars, but by Venus. It is a planet where not a single spacecraft survived for more than 2 hours.
Venus is the goddess of beauty, but this planet is more like hell. The temperature is 880 degrees Fahrenheit. The pressure is 92 atmospheres. The wind speed 450 miles per hour. And there's metallic rain. But 3 billion years ago, this hostile world was very similar to modern Earth.
Venus had the same amount of water as Earth when the planets were formed. It is possible that there was an ocean, and life could have appeared in the ocean, because when Venus was formed, the sun had less luminosity. Venus was in the habitable zone. It was too early for Earth. It was still cold on Earth, and life could not exist here. So it is quite possible that Venus was the first planet on which life arose.
And perhaps scientists will be able to detect traces of the first life forms not on the surface, but in the dense cloud layer of Venus. At an altitude of 30 to 40 miles, the atmospheric pressure just reaches 1 atmosphere. In other words, it's similar to that of Earth, and the temperature varies from 30 to 70 degrees. It is in such conditions that life developed on our planet, and even the fact that the clouds on Venus are a 75% solution of sulfuric acid is not a problem for microorganisms. In such conditions, extremophiles that feed on sulfur can survive. For example, the Archaea microphilius, which lives in hot brines on the Japanese island of Hokkaido.
On Venus, the upper cloud layer is yellowish in all spectral analyses. In the ultraviolet, we can see strips or spots. And now, one of the hypotheses is that these spots are caused by bacteria, whose ultraviolet spectrum is similar to the ones we can observe on Earth.
To study the cloud layer of Venus, NASA experts suggest launching an aircraft, an inflatable helium plane on solar batteries. This is a modified version of the Soviet probe Vega, successfully launched into the atmosphere of the planet in 1984. The American spacecraft will carry 44 pounds of scientific equipment. With its help, scientists hope to find out the composition of the clouds of Venus and perhaps to discover life.
It is assumed that the craft will also carry a microscope, which will look at the particles in the clouds. That is, if there are microbes, then it will measure their size. The size can actually be measured according to other factors, for instance, by shape. And if there are microbes, then it will identify whether they are life.
Is there life on Venus? Obviously, we will find out after 2025. The time frame of the future mission is still being discussed. But even if microorganisms are not found on Venus, the Moon, and Mars, scientists are not going to give up.
Behind the orbit of Mars, there is the so-called frost line of the solar system. This is the distance from the star where it is cold enough not only for water, but also for methane, ammonia, nitrogen, and chlorine to become solid. That is, turn into ice. Therefore, life on the surface of the planets beyond the frost line cannot exist, even theoretically. but it could still exist below the surface, in the depths of their natural satellites. Scientists suggest that under the ice crust of the moons of gas giants Jupiter and Saturn, there are warm subglacial oceans.
Thanks to the research of NASA's unmanned probes, scientists know that water in the liquid state is present on Europa, Jupiter's moon, and on Enceladus, Saturn's ice moon.
It is already quite obvious that there is a subsurface ocean on Europa, Jupiter's moon, since there is a planet-wide ice crust. In recent years, in 2014 and 2016, geyser activity was discovered with the help of the Hubble telescope. That is, emissions were discovered. There is no doubt that there is a subsurface water ocean on Saturn's nearest satellite, Enceladus, since there is powerful geyser activity on this satellite. This is Saturn's closest satellite, and so the physical explanation is clear.
The water in the depths of Europa and Enceladus is heated by geological activity. Gas giants affect satellites with powerful gravitational, or as it is also called, tidal force. Because of this force, the ice moons are constantly stretching and contracting, warming up the inside. As a result, cracks form in the ice shell, through which water bursts out, flying in huge streams into open space. It looks especially impressive on Enceladus. In the southern hemisphere, there are many geysers which emit jets of water vapor and dust particles hundreds of kilometers high. The American space probe Cassini was able to fly through them and even determine the composition of the emissions.
93% of these emissions are water or water ice. Well, they just freeze right away. About 4% are nitrogen and 1.6% are methane. About 1% is complex organic compounds. That's their composition.
Well, basically, it is possible that Enceladus may also have a fairly salty composition of its internal ocean.
That is why the possibility of the existence of life, of course, requires additional research.
Samples from the jet plume of Saturn's moon, collected by the Cassini spacecraft, are still being studied. In 2018, experts announced that they found complex organic macromolecules, the building blocks of life.
Undoubtedly, Enceladus is one of the most promising places to search for life outside Earth. But I'm afraid that we will not be able to reveal all its secrets anytime soon. After all, Saturn is about 1 million miles away.
Launched in 1997, the Cassini spacecraft took 7 years to reach Enceladus.
Jupiter's Europa is twice as close, and the conditions are almost the same.
So we hope to find life in the solar system on this celestial body first.
Moreover, unlike Enceladus, the existence of an ocean on Europa can actually be considered to be a proven fact.
If we look at the surface of Europa, it looks like a frozen lake with some cracks, loops, and so on. This is what the whole surface of Europa looks like. And this layer of ice is maybe 30 to 60 miles deep. And there are reasonable grounds to assume that under this layer, there is an ocean of water in liquid form. Moreover, its temperatures are sufficient to sustain life, and microorganisms could get energy to exist just as they do at the bottom of our oceans, from the core of the satellite, not from the sun, because it is clear that the amount of solar energy reaching there would be very low.
Scientists suggest that the conditions at the bottom of the ocean on Europa are quite suitable for the existence of thermophilic terrestrial bacteria which inhabit the so-called black smokers.
These are volcanoes at the bottom of the sea with superheated fluids, and these microbes live there. They can develop at such high temperatures. What do they eat? Well, the highest temperature microbe, for example, consumes hydrogen.
Such thermophilic organisms were found while drilling ice on the Antarctic lake Vostok, which is located under a 3-mile glacier. It is assumed that they live in hot springs at the bottom of the reservoir. Scientists consider this reservoir a testing ground for developing the technology for penetrating the ocean of Europa. Even on Earth, to drill through a 30-mile layer of ice is currently an unsolvable task. Therefore, various cryobots are being actively tested in Antarctica. These are controlled devices that use heat and can melt ocean ice and thus penetrate underwater. The probe is wired to the control unit on the surface. Various measuring instruments are also installed on it. Such devices may be used to melt ice on Europa in the future.
Water melts well, so this probe can produce a borehole just by melting ice. Of course, we'll have to resolve the issue of communication there to control its movements and so on. But I'd like to point out that these are not unsolvable problems. They have been discussed seriously, and with the advancement of modern space exploration, we can solve them.
What makes penetrating the subglacial ocean on Europa possible is its tectonics.
In the beginning, when space probes started to fly there, we found that the surface was very similar to the surface of our northern Arctic Ocean. It even had pressure ridges. The thing is that its surface is shaken from time to time. Earthquakes occasionally occur there due to tidal forces, which produces cracks. As soon as cracks form, the liquid from inside comes to the surface, and pressure ridges are formed, which, I'll repeat myself again, are very similar to those in Antarctica.
The IceFin vehicle, developed by the Georgia Institute of Technology, should help us penetrate these cracks. It has the shape of a torpedo with a length of almost 14 feet and a width of only 0.8 feet. Due to this, IceFin can sneak into small cracks and holes in the ice sheet. This vehicle, developed by American scientists, is already carrying out such tasks successfully, researching the oceanic flora and fauna off the coast of Antarctica.
Water emissions from under the ice crust of Europa will occur in the same area of the planet. Maybe we will be able to find a stable crack through which we can penetrate the subglacial ocean. But for this, we will need to study the relief of the celestial body carefully to take really detailed photos with good resolution. The European Space Agency is seriously thinking about it. Now the JUICE mission is being prepared for Jupiter and its moons. The launch is scheduled for 2022, but scientists will only receive the first pieces of data in 2030.
In the meantime, the mission to get into Europa's ocean is something for the distant future. But even without this, we can learn a lot about it. That's because on Europa, there are places where water from the subsurface ocean breaks to the surface and freezes quickly.
We can take samples of the ice from the surface, somehow melt it into a liquid state and analyze it to see if there are any microorganisms. That is, we can conduct some biological experiments. This can be actually done right on board the probe.
This is perhaps the most realistic scenario for finding life on Europa in the next 10 to 15 years. NASA and the Russian Space Agency are already developing unmanned vehicles that can land on Europa and take samples of the ice. However, the specific dates of their launch are not yet established in view of the technical complexity and high cost of such projects. But we have the experience of the landing modules on Mars, which means that this is a completely feasible task. Of course, most of all, scientists dream of sending astronauts with research equipment to Europa who would be able to dive into the subglacial ocean in a submersible. But such plans are still science fiction because of the high level of radiation.
Europa is practically in the middle of a very powerful magnetosphere and Jupiter's radiation belt. Therefore, it is possible that some missions for a more detailed study of Europa could be implemented. But the problem is the very high level of radiation.
A person without a spacesuit would get a lethal dose of radiation in less than 10 minutes.
How well does the ice crust protect the ocean of Europa from the deadly flow of charged particles? This question requires additional study. Even extreme microorganisms may not be able to survive in this ocean. The probability of finding a civilization of fish-like people, or at least fish, in the ocean of Europa is currently estimated by the scientific community as equal to 0. On the other hand, Jupiter's 2 neighboring satellites have much lower levels of radiation. It is 90 times lower on Ganymede and 54,000 times lower on Callisto, and these moons could also have oceans.
They apparently are under a much thicker crust. There is indirect evidence, in particular the fact that Ganymede and Callisto have weak magnetic fields. And the only possible explanation is the presence of an internal ocean, a salty, conductive ocean.
Penetration into the depths of these satellites is a task for the distant future. However, there are other candidates in the solar system that might have life as well. Scientists consider Titan to be one of them.
Another interesting object in the solar system where life might be found is Titan, another of Saturn's moons. Titan has a rather dense atmosphere, and the atmospheric pressure on the surface is a little higher than 1 atmosphere. That is, it is 1.5 bars. 1 bar is equal to the atmospheric pressure on Earth. The planet is very cold, naturally. It is about minus 230 to minus 320 degrees Fahrenheit on the surface. But this is the only object in the solar system besides Earth which has liquid on its surface. But it is not water as we have here. It is methane in a liquid form.
There is a cycle of liquid methane in the atmosphere on Titan, which is similar to the water cycle on Earth. When the temperature rises, evaporation occurs, methane clouds form, then rains fall, and methane seas and lakes appear.
And according to observations from the Cassini spacecraft, which conducted experiments in the atmosphere, measurements of methane molecules were made in the atmosphere, and based on their connection with other organic compounds, it was concluded that the presence of some microorganisms is possible even in a liquid methane medium. But this is less clear to us. That is, this would have to be a phase of life without oxygen, and that is a little bit different. Other chemical processes need to take place. However, there are grounds for speculating about this form of life in a liquid methane environment.
It is possible that there are life forms on Titan, and we know nothing about them. Perhaps over time, microbiologists will learn to identify them, and it will turn out that life is spread throughout the solar system. However, if that happened, we'd prefer to study the new microorganisms remotely. After all, guests from other planets could destroy humanity. What if we suddenly bring an unknown virus to Earth?
Several thousand tons of meteoritic matter fall on Earth annually, and it all falls across our planet. But here's an interesting fact. There's never been an occasion when an epidemic spread across the entire planet simultaneously. Many epidemics have occurred in Europe, which means that the European population has developed immunity to certain diseases. But when Europeans came to America, where these diseases had never existed before, new epidemics started there. That is, there is not a single case whereby an epidemic can be associated with certainty with cosmic matter, because everything that falls to Earth crumbles all over the planet. But we don't have any such examples, and consequently, maybe, even if there are any preserved forms that can survive the conditions of space, they are not active and cannot cause any kind of epidemic here. That calms me down a little.
Essentially, the exchange of matter between the celestial bodies of the solar system is constant. On Earth, scientists periodically find Martian and lunar meteorites. In the same way, in the distant past, pieces of terrestrial rock could go to other planets as a result of collisions with asteroids and comets. On September 1st, 1859, astronomer Richard Carrington discovered incredibly sized spots on the Sun. They were even visible to the naked eye. After a short time, these spots turned into 2 huge balls, which even eclipsed the Sun for a time, and then disappeared. Carrington suggested that these 2 huge solar flares, 2 mega ejections, occurred on the surface of our star, and he was not mistaken. 18 hours later, night became day in America, brightened by the northern lights throughout Europe and North America. Electricity suddenly cut out. Telegraph equipment burned down. Devices sparked, injuring the telegraph operators and set paper on fire.
The phenomenon of that autumn night in 1859 left its mark in history as a solar superstorm, and it was called the Carrington event, in honor of the English astronomer Carrington, who first observed a solar flare. But then, in the middle of the 19th century, electrical appliances were only coming into general use. Therefore, the loss of telegraph connection for a few days did not greatly affect people's lives. I wonder what would have happened to civilization if this magnetic superstorm happened in our time. After all, now everything from economy to defense is connected to electronics. Some experts compare the effects of a sudden solar storm with a nuclear war or giant asteroid hitting the Earth. Does humanity really live under the sword of Damocles, or is this just another science fiction story? To answer this, you first need to understand what triggers a magnetic storm.
The sun is essentially a plasma ball. It has a core with a temperature reaching 23.5 million degrees Fahrenheit and pressure of more than 340 billion atmospheres. Under these conditions, thermonuclear reactions are taking place inside the sun, and in the process, hydrogen is converted into helium. When that happens, energy is created, which rises from the core to the visible surface of the sun, the photosphere. Changes occur. The plasma cooling on the surface to about 10,000 degrees plunges deep into the star, while other substances rise to the top. This method of energy transfer is called convection.
It is similar to water boiling in a kettle. We heat it up from below, and as the water gets hotter, it rises, cools down, and then the steam descends again to be reheated. The same principle applies to the sun.
Solar plasma is an ionized substance consisting of charged particles, which means an electric current can be present. Due to its movement, a magnetic field is created, like winding an electromagnet. The magnetic field of the sun is variable, non-uniform. Periodically, its giant loops come to the surface of the star. Strong magnetic fields inhibit the movement of plasma from the nucleus to the surface. It loses heat faster, resulting in sunspots, which are about 2,100 degrees cooler than the surrounding areas. Therefore, they seem dark to us, although they still emit bright light.
These spots are like magnetic field tracers, local magnetic fields, and the evolution of the magnetic field is traced along them. The sun is known to experience an 11-year cycle of solar activity, although 11 years is an average period. It can vary from 8 to 14 years. In this cycle, the activity of the sun changes from minimum to maximum.
The solar minimum is the quietest period in the 11-year cycle, when there are fewer sunspots, and during the maximum, the number of sunspots is greater. Their appearance provokes flares on the surface of the star, plasma emissions and shock waves, generally called solar wind. As a result, a stream of ionized particles flies away from the sun at speeds of up to 750 miles per second. Sometimes this radioactive wind blows in the direction of Earth, and then its path is blocked by a natural shield, the magnetic field of Earth. When a shock wave like that collides with the magnetosphere, the Earth's magnetic field begins to be disturbed. It vibrates, trembles. This is what is known as a magnetic storm.
Magnetic storms are divided now into about 5 classes. The 5th and strongest class happens a couple of times each solar cycle. Storms that might make their way into history books occur once in 2 to 3 cycles. These are like strong earthquakes. There are 9-point Richter scale earthquakes. There are 3-point ones, but 9 points is rare. Such large magnetic storms are also rare. Nevertheless, we know that there has never been and never will be an earthquake which can destroy a whole continent. Similarly, there will never be magnetic storms and solar flares which can destroy everything.
In fact, the Sun and Earth systems have been fairly stable for 4 billion years, and even such phenomenon as the Carrington event do not affect our planet's protective magnetic field in the long term.
But how to explain the interruption in telegraph communication across Europe and North America? The answer is pretty simple. What is a telegraph? This is an open conductor, uninsulated, stretched for hundreds of miles, almost an ideal antenna, and enormous in size. And just as a radio receiver antenna picks up electromagnetic oscillations emitted by radio stations, the telegraph line also catches electromagnetic signals from the sun. Nowadays, there are no open wire lines. Therefore, the modern information network is much more resistant to magnetic storms. And now, in fact, the sun is approaching its minimum level of activity.
And this 24th cycle is low, below average even. And therefore, it means that there are going to be very few really powerful flares. And the next cycle, the 25th, is also predicted to be low. This essentially affects the Earth climate because there is some correlation. When the level of solar activity is low, the climate changes.
Such cases have been recorded. There was a period of long-term reduction in the number of sunspots between 1645 and 1715. Rivers in Europe started to freeze back then. Heavy rains and unusually severe winters led to several harvest failures and orchards dying out in England, Scotland, northern France, and Germany. The mechanism of the solar wind's influence on the Earth's climate is rather complicated. The Earth often experiences falling streams of cosmic rays from the galaxy and charged particles arising from the explosion of supernova stars. This galactic wind is much faster than solar wind, and it has more energy. When charged particles enter the Earth's atmosphere, they help water vapors condense, which contribute to cloud compaction. But when the solar activity is high, a strong solar wind can sweep out these rays, and in such a sophisticated way. Solar activity reduces cloudiness, and cloudiness affects the Earth's albedo, that is, its ability to reflect light. Simply speaking, when the sun is active, the atmosphere is transparent, and more heat enters it, and vice versa. When activity is lower, there are more clouds and decreasing heat fluxes.
Data from the SOHO Space Observatory testify to the abnormal calmness of the sun. The instruments placed on the spacecraft showed that the total amount of energy emitted by our star in the current cycle was lower than in the previous. In general, this gives scientists something to ponder.
In Russia, solar activity is predicted in the city of Troitsk, near Moscow. We are at the main console of the Center for Space Weather Forecasts at the Institute of Terrestrial Magnetism, Ionosphere, and Radio Wave Propagation of the Russian Academy of Sciences, or ISMARAN for short. For 20 years, they've been watching the sun around the clock.
The main tools are satellites, and the higher the satellites, the better. There are currently 3 American satellites too, flying at a liberation point, where the gravitational forces of the sun and Earth are balanced. This is 1 million miles away. It constantly flies there and rotates around the sun together with the Earth, and it always faces the sun. We are happy to use them because they are the main tools.
In the global scientific community, there's a constant exchange of data on the state of the sun. An automatic system for predicting solar weather is based on them.
The automatic system gives us a forecast. We have a team of analysts here all the time. Well, usually 3 people. We discuss it all and say, no, there's something wrong. We need to take some other factors into account. Even the US can't work with an automatic system. And in the meantime, the expert's assessment plays a big role. We change the input parameters, change all sorts of things, and we adjust the system until we think that this forecast is right. We press the button, and the machines send it to all consumers. The next day, we come and check how wrong we have been. But most of the time, we can rejoice in the work we do.
Modern tracking systems allow us to make a relatively accurate forecast for the entire 11-year solar cycle, for a year, a month, a week, but mostly short-term forecasts are in demand for several days and even hours.
The plasma from a flare takes from 1.5 to 3 days to fly. In half of the cases, the emission does not fall on the Earth, and then the forecast is declined. Then, if we observe the solar plasma near Earth, and the solar wind that has reached Earth already, we can make a forecast for 1, 2, or 3 hours. It is rather important for some technical devices that can't be turned off for a long time. And the forecast is most likely to be sent to special customers, industries that have a particular interest in this.
First of all, solar weather does not affect people and other living beings, but technological devices and various communication networks, pipelines, power lines, railways are affected by it. During a magnetic storm, the same processes occur in them as in the Faraday loop. If a coil's magnetic field changes next to it, we'll have an induction current.
And even small changes to the magnetic field lead to a very large current. For example, in the Alaskan pipeline, the current can reach 1,000 amperes. So what would happen to the pipeline? It destroys the anti-corrosive layers. Because the pipe is in a horizontal position, it is at a certain angle to the earth, so that the ions fall and do not rust. But when there's a current, it destroys this protection. And if the pipe has been designed to last for 15 years, then after 3 years it begins to rust due to this effect if it is neutralized.
In the case of railroads, currents can cause a false alarm with signals. This was discovered by Izmaran scientists when they were studying problems on the Russian railway system. If a section of the railroad is free, a certain potential difference is maintained between the rails. When a train appears between them, an electric current begins to flow. The electric current induced by variations of the Earth's magnetic field can lock the rails, which the system will read as another train on the track. As a result, the green light turns red. And although this won't cause a collision, it creates logistical problems. It's much more dangerous when large electrical grids fall victim to strong magnetic storms.
As for power lines, there is a good example of this. The blackout in Quebec on March 13, 1989, when there was a flare on the sun. It led to a magnetic storm, and the entire province of Quebec, including the capital of Canada, Ottawa, was disconnected from electricity for 9 hours. All because the system had accumulated an induction current. It first disconnects the relay, then burns the transformers. And here we have protection against lightning grounding our electrical object. But this current still flows through the soil due to salts acting as a conductor. And it flows through the earth and until reaching other energy systems and transformers and burns them.
The consequences of the Quebec blackout not only caused a power outage in millions of Canadian homes, but radio communications were lost too, while people across the world witnessed the northern lights, where previously they hadn't appeared.
The magnetic field of our planet is most vulnerable around the north and south poles. There, its lines enter Earth almost vertically. That is, those processes in the magnetosphere, which occur hundreds of miles above the equator, take place in the lower layers of the atmosphere close to the poles. And this creates many technical problems.
In the regions of the far north, a strong magnetic storm creating interference can almost completely block radio broadcasts for several days. Also, solar activity creates problems for satellite navigation systems.
Space weather also greatly influences various technical systems. It actually affects the accuracy of GPS. Since it's based on the propagation of radio waves, the influence of space weather changes and sometimes leads to errors. In reality, an error can be off by up to 300 feet. Of course, this is really huge, especially when the systems are designed to be precise to the nearest half an inch.
Landing a plane on autopilot mode, for example, even an error of just a few feet can be catastrophic. Again, a magnetic storm interferes with radio communications. Therefore, for air traffic controllers and pilots, the solar weather forecast is just as important as an ordinary weather forecast, especially when it comes to so-called transpolar flights. To save time and fuel, flights from Europe to Japan, for example, are often directed over the North Pole, and this can cause a number of problems.
During the flight, the plane communicates with the controller via satellite. Geostationary satellites have poorly visibility from the poles, so the aircraft flies over the pole using shortwave communication. If there is no shortwave connection, due to a magnetic storm, the route of the aircraft is shifted to lower latitudes, and this costs money. During magnetic storms, the Earth's magnetic field is weaker, so it doesn't protect us from cosmic radiation, and above all, its impact is the strongest approximately at altitudes of 32,000 feet. And this is the altitude used by commercial civil aviation.
Therefore, in recent years, the International Civil Aviation Organization has required airlines to take into account the radiation load on the crews of aircraft that fly specifically on transpolar routes. However, people and technology are protected both by the magnetic field and the atmosphere. Magnetic storms are much more dangerous while orbiting Earth.
During such events, high-energy particles, electrons, sometimes even protons, which affect electronic devices, appear near our planet. They are known as killer electrons. Electrons with certain energy forms, which appear in the magnetosphere or come from the sun in some cases. Well, they simply destroy electronics and knock satellites off the grid. And as you can imagine, it comes at a great cost when a satellite stops working.
As a result, about 200 satellites are lost per year. But a lot depends on them now: communication, television, internet, navigation, not to mention a country's defense and security. In many ways, this is why it's necessary to have a streamlined system for predicting magnetic storms and evaluating their consequences. The problem is that the atmosphere swells during a magnetic storm. It is heated by currents and dense layers rise up. As a result, where the ISS is in orbit at an altitude of about 250 miles, a large amount of rarefied air appears, which halts the station's motion. It loses speed and altitude. The same happens to some low-flying satellites.
One magnetic storm can make the station fall 6 miles in its orbit. It is necessary to keep this in mind in order to plan the delivery of fuel and raise the orbit again. Otherwise, it might be too late, as was the case with the Skylab, an American near-Earth space station, which studied the sun. It fell into the ocean, so this can be a very serious problem.
Therefore, in Russia, there is a domestic warning system for hazardous situations in near-Earth space. Every day, using solar weather forecast, trajectories are calculated for all satellites in the Earth's orbit so that they do not slow down, fall, or collide with each other. If necessary, measures are taken to adjust their orbits. In fact, modern cosmonautics depends almost entirely on solar activity.
A forecast for 55 days. That's because it's the amount of time it takes the sun to revolve around its axis. We send it to ballisticians at the Flight Control Center. For all the launches that might take place under our infrastructure support, we can say what day will be bad and what day will be suitable, so they plan accordingly. When they accept the plan, it comes to us, and 5 days before the launch, we go to the State Commission, which makes the decision on the exporting the launch pad. Then refuel and press the button.
Solar flares are dangerous, not only for technology, but also for astronauts, because these are streams of accelerated radioactive particles.
In 2003, consecutive flares and a stream of particles penetrated the orbit of the ISS, but fortunately missed the station. This could have led to the failure of a number of devices and life support systems, as well as radiation exposure of crew members, tens and even hundreds of times higher than the norm. In general, during periods of high solar activity, astronauts are often recommended to move to an ISS compartment with increased security. After all, radiation in space should be taken very seriously.
Spacewalks are especially dangerous. The schedule of outboard work coincides with a powerful event on the sun. Then the astronaut can receive a fatal dose of radiation.
For example, the Americans during moon flights between 1972 and 1976 were not fully aware of the dangers, and they miraculously dodged the radiation. In 1972, there was one of the largest outbreaks that had ever been recorded by scientists. Therefore, this is a significant issue, especially when we want to keep on flying. It is clear that even now, with the current level of technology, we can't live constantly on the moon, in interplanetary space, without any additional means of protection. Humanity is fortunate that the Earth has such a powerful and stable magnetic field. However, it is possible that solar activity can still affect us. This idea was put forward by Russian scientist Alexander Chizhevsky at the beginning of the 20th century. Since then, research in this field has been actively conducted in Russia. However, the results are contradictory.
A number of experts argue that a person is dependent on solar weather, that solar flares cause headaches, high blood pressure, anxiety, stress. On the other hand, during the years of the solar maximum, humanity lives under moderate and severe storms up to 50% of the time. And in 75 years of life, the average person lives through a total of 2,250 storms.
Actually, if you look at the energy contribution, deviations, anomalies of solar activity, this is an insignificant part of what the sun produces. Totally insignificant. And organisms have become accustomed to this during evolution. Yeah, you and I have developed a mechanism to adapt to increased radiation. We tan in the sun. Our bodies immediately begin to respond to increased radiation. Simply put, minor changes to solar activity are not dangerous for us.
Indeed, magnetic storms have no direct impact on human life, but on the other hand, under their influence, changes occur in the environment. For example, atmospheric pressure, and naturally, the human body reacts to it. There are statistics which claim that during large magnetic storms, the number of heart attacks and strokes increases by about 20%.
Это отражается на самочувствии людей всех.
This is reflected in the well-being of all people.
Веселых,
But young, healthy, cheerful people have a number of protective mechanisms.
которые все приводят в норму.
Weak people, so to speak, senior people who are the first to react to this, especially those who have cardiovascular conditions.
Они реагируют, всегда реагируют, поэтому мы тоже...
Therefore, we work alongside doctors. We have patented a method in this area called a way to combat magnetic storms for individuals with myocardial infarction and hypertension.
С инфарктом миокарда и гипертонии.
And it explains how to deal with it. Get our forecast and take medicine as prescribed by doctors. When the storm ends, stop.
По указанию медиков.
To do this, we have 2 telephone answering machines.
Для этого мы еще...
People can call us free of charge round the clock to find out about the state of the geomagnetic field and the forecast.
Где говорится состояние геомагнитного поля и прогноз.
The issue of solar weather's influence on the human body requires additional research. Although the sun has been studied by astronomers for a long time, it still harbors many mysteries. For example, why the duration of a solar cycle can vary from 8 to 14 years, and why has the Wolf number, which measures the number of sunspots, varied from 45 to 190 in the last 300 years. To answer these questions, Ismaran and Roscosmos are preparing a new space mission to the sun.
Now the project, Interheliozone, is being developed. It is aimed at studying all these problematic issues of solar physics, studying space weather, its impact on Earth, and so on. This year and next year, other agencies, NASA and the Institute for Systems Analysis at the Russian Academy of Sciences, are planning to launch spacecraft which will get closer to the sun, because all the possibilities of studying the sun from the orbit of the Earth have already been exhausted to a large degree.
The Interheliozonde satellite will study the sun and the near-solar environment from a distance of 26 to 30 million miles. The satellite will investigate solar active phenomena and related effects, the corona of the sun and the solar wind, the polar regions, and the heliosphere.
Perhaps in the near future, mankind will learn to predict space weather down to the minute. Without this, the further development of astronautics, the study and colonization of other planets of the solar system, is simply impossible. My name is Vladimir Surdin. See you next time on A Guide to the Universe.